Today's topic is from Chapter 3, Lesson 5, Solving Two-Step Equations. Our essential question, how can you use algebra tiles to solve a two-step equation? We're actually not going to use algebra tiles. We are going to use a process that involves inverse operations. I'm going to give you some notes that you can copy down into your packet. We're going to follow these steps to solve two-step equations. We're going to practice them, and then I'm going to actually teach you another way of doing it that might help you to remember those steps more easily. So let's copy down the steps that you're going to need into your note packet. The steps for solving a two-step equation involve the first step, which is to undo the addition or subtraction. Write it like this. Undo the addition or subtraction, which will always be the number by itself. After you get rid of the addition or subtraction, step 2 will be to undo the multiplication or division part. And that will always be the number attached to the variable. And then once you are done getting rid of those two pieces, step 3 will be to substitute to check. And feel free to pause the video if you need some time to copy those down, but you do want to have them so that you can refer back to them. I'm going to follow those steps in example 1, where I'm going to solve this two-step equation. And if you notice, the steps are the order of operations backwards. Since we're undoing it, we're going backwards in the order of operations, where we're doing the addition and subtraction first before the multiplication or division, which is opposite in the order of operations. You always multiply or divide first and then add or subtract when you're solving the equation. Well, we're solving for the variable inside the equation, so we're working it backwards. So if I look at my first example, negative 3x plus 5 is equal to 2. I want to get rid of this plus 5. So we want to think to ourselves, what is the opposite of adding 5? What the inverse operation of addition is, which would be to subtract 5 from both sides. Remember, we draw our line to remember that what we do on one side of the equal sign, we must do the same thing on the other. So on the left-hand side, we have 5 minus 5, which would cancel out to 0. And on the other side, we have 2 minus 5. And if we're thinking about our integer operations, it becomes 2 plus negative 5. Keep change opposite. And that gives me an answer of negative 3. Negative 3 is what we end up with on that side, and I'm going to bring down what is still up here, negative 3x. So now I have negative 3x is equal to negative 3, and I want to undo this negative 3, which is being multiplied by x. The inverse operation of multiplication would be to divide. So in order to get rid of that multiply by negative 3, I'm going to divide by negative 3. On both sides of the equal sign. Negative 3 divided by negative 3 gives me a positive 1, or just simply positive x. And negative 3 divided by negative 3 on the other side also gives me a positive 1. So I did step 1 and step 2. I undid my addition by subtracting. I undid my multiplication by dividing on both sides. I'm now going to do step 3. I'm going to label these for you guys. This was step 1. This was step 2. Step 3 is going to be that we substitute to check, which means I'm going to replace that 1 in for x into the original equation, which makes it say negative 3 times positive 1 plus 5 should equal 2 if we did it correctly. So I'm going to follow PEMDAS now, my order of operations. I need to multiply before I can add. Negative 3 times 1 is negative 3. Negative 3 plus 5, I'm looking at adding integers where the signs are different, which means we really subtract. Different signs means find the difference. The difference between 5 and 3 would be 2. The sign of the higher absolute value would be that positive 5. So I end up with 2 is equal to 2, which is a true statement, which means that my answer is correct. I'm going to do another one with you before I set you off on your own. Let's look at number 1 in the on your own problems. First part of number 1 that we need to get rid of, step 1, undo the addition or subtraction. Again, you can see an adding of 12. To undo plus 12, we would minus 12 from both sides. 12 minus 12 cancels out to 0, leaving me with just the 2x still over here. 4 minus 12 on the other side. Again, if you want to think about those integer rules, you have keep, change, opposite. You're looking at 4 plus a negative 12. Your signs are different, therefore you find the difference, which would be 8. Take the sign of the higher absolute value, which would be that negative 12, so you end up with a negative 8 on that side. It's now a one-step equation. 2 times some number is equal to negative 8. We're going to undo that multiplication again by dividing. So we're going to divide by 2 on both sides of the equal sign. 2 divided by 2, any number divided by itself is 1, leaving me with just 1x, which we simply write as x. And negative 8 divided by a positive 2. When your signs are different, it's always a negative answer, and 8 divided by 2 would be 4, giving me the answer of negative 4. I'm then going to substitute to check, always checking our answers. So we've got 2 times x is now a negative 4, plus 12 equals 4. Multiply first, giving me a negative 8, plus 12 is equal to 4. Here your signs are different, therefore you find the difference. The difference between 12 and 8 is 4. Taking the sign of the higher absolute value, which would be that positive 12. 4 is equal to 4 is a true statement, therefore it checks out. See if you can do number 2 on your own. That is just like the other ones that we did. Number 3, before you attempt it, there's a 3 on the outside of those parentheses, which means that you need to distribute this 3 first before you can solve. So let's do that together now. If I do 3 times x, that leaves me with 3x. And 3 times a negative 4 would leave me with a negative 12, and that's still equal to 9. Now you're going to solve that one by following your steps. So please pause the video, attempt number 2 and number 3, and then come back and check your answer. In number 2, the first part that you should have been getting rid of would be that plus 9. We want to undo that addition. To undo it, we are going to subtract 9 from both sides of the equal sign. A 9 minus 9 cancels out, leaving me with just negative 5c over there. On the other side, thinking about our keep, change, opposite rule, keep, change, opposite, you're looking at negative 16 plus a negative 9, which is going to give you a negative 25. Now we have to undo that multiplication of that negative 5, therefore we're going to divide both sides by negative 5. Negative 5 divided by negative 5 leaves me with a positive 1c, or simply c. Negative 25 divided by negative 5 leaves me with a positive 5. Signs are the same, your answer is always positive. You're then going to substitute that value back in to check. Your equation now states negative 5 times positive 5, which I just substituted in for c, plus 9 should equal negative 16. We're going to multiply first. Negative 5 times positive 5 leaves me with a negative 25. Plus 9 should be equal to negative 16. Integer rules state that when you are adding numbers with different signs, you really find the difference. So 25 minus 9 would leave me with 16. We're going to take the sign of the higher absolute value, which would be that negative 25. I end up with negative 16 on both sides of my equal sign, making my answer true. We're correct. In number 3, we distribute it first to solve. We're now going to follow the steps. First step would be to undo that subtraction of 12, and the opposite of subtracting 12 would be to add 12 on both sides. It's the first time we had one like that where we had a subtraction problem. We know the inverse of subtraction is to add. So all we have to do is add 12 to both sides. A negative 12 plus 12 takes me to 0, canceling that out, leaving me with just 3x on this side. And 9 plus 12 would give me a positive 21. I now need to undo by multiplying by 3, which I would do by dividing both sides by 3. 3 divided by 3 leaves me with x, and 21 divided by 3 is 7. You're then going to substitute 7 back into the equation. We'll go with the very original equation. 3 times the quantity, 7 minus 4, should be equal to 9. Following the order of operations, we would do my parentheses first. 7 minus 4 is 3. And 3 times 3 gives me 9. Since 9 is equal to 9 is a true statement, our answer of x equals 7 is correct. Let's take a look at the next one. This one is going to involve some division now. For all of those, we were either getting rid of the addition or subtraction, and then we were undoing the multiplying by dividing. So now we're going to take a look at an example that will involve division, which we would have to undo by multiplying.
Excuse this interruption, is Shay
So we'll start off example 2 by looking at the addition or subtraction part, which I see a minus 1/2. So we need to undo that first. What's the opposite of subtracting 1/2? We're going to add 1/2 to both sides of the equation. Negative 1/2 plus 1/2 cancels out to 0, leaving me with x divided by 8 on this side. And negative 7 over 2 plus 1/2. We can plug that into our calculator, or since they have a common denominator, we're looking at negative 7 plus 1, which would give me a negative 6 over 2, which we could even convert simply like negative 3 if you'd like. So we're looking at x divided by 8 equals negative 3 when we simplify that answer. So now we have to undo that division. It says x divided by 8. How do we undo dividing by 8? We're going to multiply both sides of the equation by 8. Times 8 there, times 8 on the other side as well. So you can see that this, if I want to write it as a fraction, when you multiply fractions and you have the same number diagonal to each other, they cancel out to become 1s. So if I make these all 1s, I'm left with 1 times x, which is x, and 1 times 1 on the bottom, which is 1. Well, x divided by 1 is just simply x. Right? So whenever you have the number diagonal to that you're multiplying by, and it's the same number, they will always cancel out and always leave you with just x by itself. On the other side, we need to do our multiplying by 8 as well. Negative 3 times 8 would leave me with a negative 24. And then, just like always, going to substitute to check. So x is now negative 24. I'm going to rewrite my problem. Negative 24 divided by 8 minus 1/2 should equal negative 7 over 2. You can plug that right into your calculator to see what you get. Your calculator will probably give you a simplified answer of negative 7 over 2. And if you understand that negative 7 over 2 is really an improper fraction, we can change that to a mixed number by saying 2 can go into 7 3 times with 1 left over. So you're looking at negative 3.5 or negative 3.5. And if you plug negative 24 over 8 minus 1/2 into your calculator, it's going to give you one of those two answers. Since it was a fraction, it will most likely give it to you as a fraction. But you have to be able to recognize that that fraction and this decimal are equivalent. They're the same. Therefore, our answer is correct. All right, instead of going through the steps of subtracting fractions and changing to common denominators, something that we should already know how to do, I'm using that calculator to check to speed up the process. So I will do one more with you, and then I'll set you off on your own for the next two. In number 4, I need to undo my addition or subtraction piece first. I see add 6, so I need to do its opposite or its inverse, which would be to minus 6. We're going to do that from both sides. 6 minus 6 is 0, leaving me with m divided by 2 over here. And 10 minus 6 is 4. To undo m divided by 2, you should be multiplying both sides by 2. See how they're diagonal to each other? They cancel out, leaving you with just m. And since you multiplied by 2 there, you must multiply by 2 over there. So you're left with m is equal to 8. Again, you will always substitute these back in to check. So m is now an 8, so I'm going to rewrite it as 8 divided by 2 plus 6 equals 10. And we can simplify that. 8 divided by 2 is really 4, and 4 plus 6 gives me 10 on both sides of my equation, leaving me with a correct answer of 8. So I'm going to ask that you pause the video now and see if you can solve numbers 5 and 6. Pay attention to the fact that you now have a negative fraction there. See if you can figure out what to do. Try those two, pause your video, and then come back and check your answers. In number 5, we're going to undo that addition of 5 first, and we're going to do that by subtracting 5 from both sides. Draw your line. 5 minus 5 cancels out to 0, leaving me with a negative z divided by 3. And on the other side, 9 minus 5 would be 4. You now need to undo that dividing by 3, and since this is a negative, we want to get rid of that negative, because I don't want to be left with a z. So what kind of number would I multiply a negative by to get rid of a negative? Well, we know that a negative times a negative is a positive, so that's what we want to multiply by, not just a 3, but a negative 3. That way, we're not only just canceling out the 3, we're getting rid of that negative sign as well, leaving me with a positive, because a negative times a negative is a positive z. And since we multiplied by negative 3 on that side, we need to do the same thing on the other side. Positive 4 times a negative 3 would give me a negative 12. So if you ended up with a positive 12 here, that's because you never got rid of this symbol. So if your answer was positive 12, negative z is actually equal to positive 12. And we don't want to know what a negative z is. So again, you're thinking about getting rid of that negative sign. There's really a negative 1 there. So if you ended up with negative z equals positive 12, you would get rid of that negative sign by dividing both sides by negative 1. It's just another way of doing it. And negative 1 divided by negative 1 would then give you your positive z, and a positive 12 divided by negative 1 would again give you that negative 12 as your answer, which is the correct answer. We're going to substitute that back in. I already have a negative sign here. I'm plugging in a negative 12 divided by 3 plus 5 equals 9. So these two negatives here, what do two negatives give you? Negative divided by negative is a positive, so that's really a positive 4. Plus 5 equals 9. Now you're looking at 9 is equal to 9, correct answer. So you must have had that negative answer here. Otherwise, you would end up with a negative 4 plus 5, and negative 4 plus 5 does not give you positive 9. That's why it is so important to substitute back in to check to make sure you're getting the same answer on both sides of your equation. Because if you're not, you're making a mistake, and then you found that you go back and find that mistake once you know that it's there. Moving on to number 6. I want to get rid of my addition or subtraction part first. And remember in our notes we wrote that that's the number by itself. Well, 4 is not by itself. Even though it says plus 4a, 4a is the multiplication part. The 2/5, which has no sign in front of it, which means it is a positive sign. We don't have to write it. That's a positive 2/5. That's the part we need to get rid of first. So all they did was they switched these guys. Alright, you were used to seeing the variable come first, and if you want to rewrite it with the variable first, it would say 4a plus 2/5 equals negative 6/5. That's still the same equation, if that helps you. Or if you keep it like the original one up here, you're getting rid of a plus 2/5, therefore what are we going to do both sides? We're going to subtract 2/5. I'm going to keep with this one since I rewrote it. I'm going to start by subtracting 2/5 from both sides. These guys cancel out, leaving me with 4a over here. On the other side, if I want to talk about my integer rules, I've got my keep. Instead of minus 2/5, I can say plus a negative. Excuse me. So we're looking at negative 6 plus negative 2, which give me a negative 8 over 5. They had like denominators for us already. And if I want to change that improper fraction to a mixed number, 5 can go into 8 a negative 1 time with 3 left over. So it's really negative 1 3/5, if that helps. So we've got 4a equals, you can still keep it as that negative 8/5 or rewrite it as negative 1 3/5, whatever you'd like to work with. I need to get rid of that 4 that's being multiplied by a, therefore I'm going to divide both sides by 4. These cancel out, leaving me with a. Negative 1 3/5 divided by a positive 4 leaves me with a negative 2/5. And you can plug that into your calculator. It's a division of fractions, so you would have to do keep, change, flip if you were doing it by hand. You would then want to also keep this as your answer here, because you would have to change that back to an improper fraction if you're doing it by hand. But the skill right now is to solve two-step equations. I'm not worrying about those other skills that we can just plug into our calculator. I'm now going to substitute that answer to check. So we have 2/5. I'm going back to the very original guy up here. 2/5 plus 4 times negative 2/5 should equal negative 6/5. Order of operations would mean that we would have to multiply first. Again, we can plug that into the calculator. 4 times negative 2/5 gives me a negative plus negative 1 3/5. I'm then going to add that negative, and that ends up giving me a negative 1 1/5. We have to be able to recognize, are they the same? So I've got a mixed number and an improper fraction. If you convert negative 6/5 to a mixed number, let's see what it gives you. We know it's going to be negative still. 5 can go into 6 one time. That takes me to 5. I need to get to 6. Therefore, there's 1 left over, and our denominator always stays the same. And you can see that those two match, making it a correct answer. Moving on to the next example. In example 3, I've got 3y minus 8y. Well, in order to do anything first there, I've got to combine some like terms since I have two variables that are the same. Whenever your variables are the same, you're going to combine your like terms. Right? You can see the steps that are there for you. So when I combine them, 3 minus 8 is really 3 plus negative 8. I'm adding and my signs are different, therefore I'm really finding the difference, which would be 5, because 8 minus 3 is 5. And I would take the sign of the higher absolute value, which is that negative 8, leaving me with negative 5y equal to 25. So the two steps here really aren't the original ones that we are following. This two-step is combining like terms for step 1. Then you just have a one-step equation left, and we're going to solve that by dividing both sides by negative 5, because this is a multiplication problem. It's saying negative 5 times y. To undo multiplying by negative 5, we divide both sides by negative 5. That way these two cancel out. Two negatives give me a positive y. And 25 divided by a negative 5 would give me a negative 5. My signs are different. My answer should be negative. I can then substitute that value in to check it. 3 times negative 5 plus 8 times negative 5 should give me 25 if my answer is correct. Order of operations would make me multiply before I can add. 3 times negative 5 is negative 15. 8 times negative 5 is negative 40. And when I add those two negatives, a negative 15 plus a negative 40, I'm sorry, the original equation said minus, that's my bad. This should be negative 5 minus 8 times negative 5. Maybe there was something wrong there. So I've got negative 15 minus negative 40, and that should be equal to positive 25. I'm going to look at keep change opposite my integer rules. Negative 15 plus a positive 40. My signs are different, therefore I should be subtracting, finding the difference. 40 minus 15 is 25. Take the sign of the higher absolute value, which is positive. 25 equals 25 would be my true statement. Right? I'm going back up here to my original problem, which said 3y minus 8y. Remember, I changed it to plus negative because I was looking at those keep change opposite rules. But you want to, when you're substituting in, you want to use the original equation. Alright, so that's your example for combining like terms, which you will try in a couple minutes. Let's go over the word problem first. So your real life application of all of this says the height of the top of a roller coaster hill is 10 times the height h of the starting point. The height decreases 100 feet from the top to the bottom of the hill. The height at the bottom of the hill is negative 10 feet. They're asking us to find h. So if you look at the chart, the height at the start is h. Top of the hill, the height at the top of the hill is 10 times the starting height, so that's 10h. And the height decreases by 100 feet, which means it's going down, so they're subtracting 100 from it. So here's our expression, 10h minus 100. The height at the bottom of the hill is negative 10 feet. They want us to solve 10h minus 100 equals negative 10. That will help you to find h. So I'm going to rewrite that to make it a little bigger. 10h minus 100 equals negative 10. So I've got my two-step equation here. What's the first step that I should be taking? I should be undoing my addition or subtraction. I see subtracting 100, which means I should be adding 100 to both sides. These are opposites of each other. They cancel out to 0, leaving you with just 10h over here. And negative 10 plus 100, different signs, find the difference, which would be 90. Sign of the higher absolute value would be that positive 100, giving you positive 90. You now need to get h alone. The opposite of multiplying by 10 would be to divide by 10 on both sides. 10 divided by 10 would give me 1, h, or simply h. And 90 divided by 10 would be 9. And in the end, substitute to check. So we're going to substitute 9 in for h. So I've got 10 times 9 minus 100 should equal a negative 10. Order of operations means we would multiply first. So 10 times 9 is 90. 90 minus 100 should equal negative 10 if we did it correct. Keep change opposite integer rules. Keep change opposite. We've got two different signs, which means we should be finding the difference. 100 minus 90 is 10. Take the sign of the higher absolute value, which would be negative. We're left with negative 10 is equal to negative 10, which makes our answer of h equal 9 correct. So now let's take that and look at some on your own problems. 7, 8, and 9 looks like you have some combined like term problems. So you want to combine your like terms before you try to solve these equations. To do that, and then follow your rules for either one-step or two-step equations to get your variable by itself. So I'm going to have you pause the video, also try number 10 as well, and then come back and check your answer. So in number 7, our like terms here are actually our constants, our numbers. So I've got 4 plus 3, which would give me 7. So I've got negative 2y plus 7 equals negative 9. After combining like terms, we're then going to follow the steps for two-step equations. So the first part, on doing the addition or subtraction, I see add 7, so let's subtract 7 from both sides. 7 minus 7 would cancel out, leaving you with just that negative 2y left over there. And the negative 9 minus 7, we would rewrite using keep change opposite, making it negative 9 plus negative 7. Your signs are the same. You add them and keep that negative sign. That gives me negative 16. You then have to undo your multiplication by doing the inverse, which would be to divide both sides by negative 2. Negative 2 divided by negative 2 leaves me with y. Negative 16 divided by negative 2 should have given you a positive 8. Substituting those values back in, I'm going to move this down and give me some space. We're going to check it. 4 minus 2 times 8 plus 3 should equal negative 9. We're going to multiply first. We've got a negative 2 times a positive 8, which would give me a negative 16. And then 4 minus 16 plus 3 ends up giving me a negative 9, which is equal to negative 9, so it checks out. In number 8, combining your like terms first, 7x minus 10x. Keep change opposite. You're looking at 7 plus a negative 10. Find the difference, which would be 3. Take the sign of the higher absolute value. You're left with negative 3x equals 15. To undo that multiplication, you should be dividing both sides by negative 3 to get x alone. These two cancel out to x. And 15 divided by negative 3 would be a negative 5. Substituting that back into check, I've got 7 times negative 5 plus 10 times negative 5 should equal 15. 7 times negative 5 is a negative 35. Oh, I did it again. This is not plus. This is minus. And we could look at that as a negative 10 times a negative 5, which would be plus 50, equal to 15. Your signs are different here, therefore you're going to subtract 50 and 35, leaving you with 15. Taking the sign of the higher absolute value, which is 50, and that one checks out. In number 9, you've got some like terms, those m's over here. So 1 3/10 minus 2 1/10 will leave you with a negative 8/10 m. And that's set up equal to a negative 8. To undo the multiplication by that negative 8/10, you should be dividing both sides by negative 8/10. That leaves you with m alone. Must do one thing on one side, you must do to the other. 8 divided by a negative 8/10 will leave you with a positive 10. You're then going to substitute that into check. Is negative 8 equal to 1 3/10 times 10 minus 2 1/10 times 10? Well, 1 3/10 times 10 is 13, and 2 1/10 times 10 is 21. And if you want to think in terms of keep change opposite, you find the difference between those two, which would be 8. Take the sign of the higher absolute value, which is negative. Negative 8 equals negative 8 is a true statement. Therefore, it is correct. And in the real life problem, we're going back to example 4. Now they're saying the height at the bottom of the hill is negative 5 instead of the original number, which was, I believe, negative 10. Yes, so we're using the same exact equation, but the answer is now set up equal to negative 5 instead of negative 10. So here's the equation that they wanted you to solve, which means we're going to undo that subtraction piece first. We should be adding 100 to both sides. These guys cancel out, leaving me with 10 each. Negative 5 plus 100, we should be finding the difference and taking the sign of the higher absolute value. The difference is 95. 100 is bigger, therefore it's a positive 95. I then need to divide both sides by 10 to get h alone. That cancels out to h. 95 divided by 10 would give me a height of 9 5/10 feet. Then we can substitute that value in to check to make sure we did it correctly. So we're looking at 10 times 9 5/10 minus 100 should give me negative 5. 10 times 9 5/10 is 95. 95 minus 100. Again, keep change opposite. Find the difference, which would be 5. Take the sign of the higher absolute value, which is negative. And you can see that you end up with the same answer on both sides. So remembering those steps, undoing the addition and subtraction first, and then undoing multiplication and division, and then substituting to check, I just have another way of kind of helping you remember those steps. We call it the Tupac method. So Tupac is a famous rapper from way before your time. Some of you might know him. They want you to identify Tupac, and Tupac is always the most important person when you are at a concert. So he's going to be the most important person in our equation, which is always going to be the variable, because that's who you want to get alone. And when you're at a concert, the person that's closest to that famous person is always their bodyguard, the person that needs to keep them safe. So the person that you're going to identify to the bodyguard, the number that is closest to Tupac, is going to be the number that's attached to him. The coefficient, if you will. Then you're going to identify the fans, and your fans are always separated from Tupac by either an addition or subtraction sign. So our fans are, close to the stage. They're close to that famous person, but they're not quite as close as the bodyguard. The door to the concert will be your equal sign, and the people on the other side of that door are just going to be some more fans, those fans that couldn't get into the concert themselves. So the thing we're going to do is we're going to always get rid of our fans first. Well, we're going to do that by adding or subtracting to get them away using those inverse operations. Then we're going to get rid of our bodyguard, which would be the multiplication or division piece, and we're going to use their inverse operations. And then we're going to get Tupac all by himself. We're going to get that variable. So here's just 3 more examples of two-step equations. Looking at these two-step equations, here's Tupac, my variable. This would be my fans. And here is my bodyguard. Call it BG for bodyguard. Alright, and T for Tupac, he's our famous person. So how would I get rid of my fans from this concert first? I'm going to add 5 to both sides. These cancel out, leaving me with just my bodyguard and Tupac. And a negative 10 plus 5 gives me a negative 5. I can then get rid of my bodyguard by dividing both sides by 2. That leaves me with Tupac alone. And a negative 5 divided by 2 would give me a negative 2 5/10, or negative 2 1/2 if you want it as a fraction. So as I'm teaching this, I usually say, who are we going to get rid of first? And the kids will say, the fans. And then they'll say the bodyguard. So it's just a way of helping you to remember those two-step rules. You always get rid of your fans first. My fans here would be my 9, number by itself, leaving me with Tupac, P, and the bodyguard, negative 4. And negative 5 plus 9, keep change opposite, would give me a negative 14. And then I would divide both sides by 4. That would leave me with positive P, which is Tupac by himself. And this would leave me with, I'm going to change it to a mixed number. 4 goes into 14 3 times. That takes me to 12, 2 left over. 2 negatives give me a positive, and that can be simplified to 3 1/2. And in the last one, even though the variable is on the other side, we're still going to get rid of our fans first. My fans here are negative 2, so I'm going to add 2 to both sides. Cancel out, leaving me with the bodyguard and Tupac. And 11 plus 2 is 13. Then get rid of my bodyguard by dividing by a negative 5 on both sides. That leaves me with X over here. And that would leave me with a negative 2 3/5. Alright, so just another way of helping you to remember two-step equations. You get rid of your fans first, which is your addition or subtraction part, and then your bodyguard, your multiplication or division piece. And that variable is always your famous person, whoever you want it to be. If you don't like Tupac, pick another famous person that will represent that variable.